In this lesson, we are going to talk about how to expand binomials. Just to recall that a binomial is a polynomial of two terms. For instance, in the example given here, 3x minus 5 is a binomial because it has two terms. One term is 3x and the other term is negative 5. Another one is 5x squared plus 4x exponent 6. Two terms again. 5x squared is one term and positive 4x exponent 6 is another term. Now, when we are multiplying two binomials together, the one thing that you have to make sure is that every term in one bracket here has to be multiplied by every term in the second bracket. Now, how you are going to multiply, it depends on you. What is the easiest way of multiplying? The way that I'm going to explain here is that I'm going to take the first bracket and I'm going to multiply every term of the first bracket by the second term. After you multiply all these terms together, the last step is just to simplify, meaning take the like terms together, either add or subtract, and then get the final result. For example, here, if we are trying to multiply 3x plus 5 times 2x minus 7, the way we do it is that we take every term of the left bracket and then multiply it by every term in the second bracket. The first term on the left bracket is 3x. The first term on the second bracket is 2x. Multiply these two together, you get 6x squared, which is here. Now take the first term of the first bracket, which is 3x, multiply it by the second term in the second bracket, which is negative 7. 3x times negative 7 gives you negative 21x, which is here. Now take every term in the first bracket, now it's term 5, which is 5, multiplied by the first term in the second bracket. So 5 times 2x gives you 10x, which is here. And finally, multiply the second term of the first bracket, which is 5, by the second term in the second bracket, which is negative 7. 5 times negative 7 is negative 35, which is here. Now the last step is to combine the like terms. There is no like term to 6x squared, so we just write 6x squared. Negative 21x and plus 10x, they are like terms, because both of them, they have x and the exponent is 1. So negative 21 plus 10 gives you negative 11x. And finally, you have negative 35, but there is no other constant, so you just write negative 35. So the final answer is 6x squared minus 11x minus 35. In the first example, we are supposed to expand 2x plus 1 times x plus 4. So again, I'm going to write 2x plus 1 times x plus 4. Now I'm going to draw arrows from every term in the first bracket to every term in the second bracket. So starting with term 1 in the first bracket. So one arrow goes to the first term of the second bracket and another arrow goes to second term. So 2x times x gives me 2x squared, because x times x, they have the same base, so you add exponents. The exponent of the first one is 1, the exponent of the second one is 1, you add them, 1 plus 1 is 2. Now you multiply 2x by 4. 2x times 4 gives me 8x. Now we do the same thing with the second term of the first bracket. So one arrow goes to the first term, the other arrow goes to the second term. 1 times x gives me 1x or x. So let's write 1x. And 1 times 4 gives me 4. Now I'm going to take the like term. There is no like term to x squared, so I'm just going to write 2x squared. 8x and 1x, they are both like terms because x in both of them, they have exponent 1. So 8 plus 1 gives me 9x. And then the only thing which is left is plus 4. So the final answer is 2x squared plus 9x plus 4. The next example is expanding 2x minus 7 times 4x plus 9. So again, 2x minus 7, 4x plus 9. Again, I'm going to draw my arrows, the first term in the first bracket to the first term of the second bracket, and the first term to the second term of the second bracket. 2x times 4x gives me 8x squared. 2x times 9 gives me 18x. Now I go to the second term. Negative 7 and 4x, negative 7 and 9. Negative 7 times 4x gives me negative 28x. Negative 7 times 9 gives me negative 63. There is no like term to x squared, so I'm going to have 8x squared. Now 18x and negative 20x are like terms. Add them together, we get negative 10x. And the only thing which is left is constant, which is negative 63. So the final result is 8x squared minus 10x minus 63. The next example wants us to expand 3x minus 5 times 3x plus 5. Again, I draw the arrows, first term on the first bracket to the first term of the second, and then the first term to second term. 3x times 3x gives me 9. Remember, exponent here is 1, exponent here is 1. They have the same base, add the exponents. 1 plus 1 is 2, so it's 9x. Then 3x times 5 gives me 15x. Now the second term, negative 5 multiplied by 3x, negative 5 by 5. Negative 5 times 3x gives me negative 15x. Negative 5 times 5 gives me negative 25. Now again, there is no like term to 9x squared, so I get 9x squared here. 15x and negative 15x gives me 0. And then we are left with negative 25. So the product is 9x squared minus 25. This brings us to a very interesting fact here that whenever you are multiplying a binomial of the form a minus b times a plus b, when you simplify this one, you always get a squared minus b squared. This one is called the difference of squares. If you look here, this is difference of squares here because 9x squared is the square of 3x. 25 is the square of 5. The difference of square, you can see that if I expand this one, I get a squared minus b squared. Now, in this case, if I take square root of 9x squared, I get 3x. If I get the square root of 25, I get 5. So this means I have to end up with a minus b times a plus b. Now, if you look here, we said that square root of 9x squared is 3x here. So this is my a. The square root of 25 is 5. This is my b. So I get a minus b, which is 3x minus 5, times a plus b, which is 3x plus 5. This is a fact that you are going to use a lot later on. The next example, we are supposed to expand 2x plus 3 squared. To expand this one, I know square is repeated multiplication twice. So this one I can write 2x plus 3 times 2x plus 3. Now I do the same thing, first term times first term times second term. 2x times 2x gives me 4x squared. 2x times 3 gives me 6x. Now second term multiplied by the first term, second term multiplied by second term. 3 times 6x gives me 6x. 3 times 2x gives me 6x. 3 times 3 gives me 9. Now no like term to 4x squared, so I'm going to end up with 4x squared. 6x plus 6x gives me 12x. And then finally 9. Now in general, when you are trying to find a plus b squared, this is the same as a plus b times a plus b. Now if I do the multiplication again, a times a times b, a times a gives me a squared, a times b gives me ab, b times a and b times b, b times a gives me ba, b times b gives me b squared. Now there is no like term to a squared, so I get a squared. ab and ba are the same. 1 times 2 is the same as 2 times 1. So here I get plus 2ab plus, and the last one is b squared. Now this means that a plus b squared, you just square the first term, which is a squared here. Then you square the second term, which is b squared. And then you multiply first term by second term, and then multiply the result by 2. You get this one. Here, if I use this technique, I'm going to say 2x a squared, 2x squared is going to give me 4x squared. Second term squared, 3 squared is 9, plus multiply the two terms, 2x times 3 gives me 6x, then multiply it by 2 again, as it says here. So 6x times 2 gives me 12x, which is exactly the answer we got by expanding it term by term.